Hello students, welcome back to today's class on direct and inverse proportions. In the last class we have discussed what is a direct proportion, and we also discussed a couple of examples or solved problems based on that. And in today's class we're going to discuss what is inverse proportion, and from there we're going to discuss the other applications. Right, my name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So let's try to have a small recap of what we have discussed in the previous class. Okay, we discussed what is a ratio. In the lower class only you have learned what is a ratio, but once again we have a small recap of what is A is to B. A is to B, the ratio A is to B is nothing but A by B. Okay, A is to B is equal to A by B, the fraction value A by B, which indicates how many times B is the quantity A. How many times B is the quantity A? For example, we have, let's say, three balls. We have three balls, okay? So let's say this is blue ball and these two are green balls. Blue and green. So total we are having three balls, correct? Okay. So out of the total three balls, out of all the three balls, only one ball is blue. Only one ball is blue. So the ratio of blue balls is 1:3. 1 by 3. And what are the number of green balls? We're having 2 out of the total 3. So the point is, how many times B is A? How many times of 3 is 2 balls? How many times of 3 balls is 1 ball? Right? So that is what we say ratio. And the ratio A is to B. The first one we said it is called antecedent, and the second one B is called consequent. Antecedent and consequent. Correct? Moving forward, we also discussed what is a proportion. Right? And when we are discussing proportion, I said we are comparing two ratios, not just one. We're comparing two ratios. One A is to B and the other C is to D. And when these two values are equal, A is to B and C is to D, when these two values are equal, we say this is in a proportion. These two are in proportion. A, B, C, D are in proportion. Right? We read this as A is to B is proportionate to C is to D. A is to B is proportionate to C is to D. This can also be read as A is to B is as C is to D. Right? And moving forward, we also discussed what is a direct proportion. What is direct proportion? Okay, so when we have a ratio, when we have x and y terms, when both are being changed, okay, so x and y are two quantities such that both of them increase or decrease together. That means as x increases, y should also increase. As x increases, y should also increase, or as x decreases, y should also decrease. So such type of thing we say they are direct proportion. Okay, and the ratio x by y should remain the same. Although x and y are increasing, all they are decreasing, the value of x by y should not change. The value of x by y remains constant. Then we say x is directly proportional to y. We discussed that in the last class, correct? Okay, we also gave some example. A girl where the age is increasing, even her height is also increasing. Correct? So I'll give a small example. Yeah, 1 second. Yeah. So if we have, let's say 1 by 2, the ratio 1 and 2, 1:2. And in case as 1 is increasing, let's say it is increasing to 3 and 2 is also increasing to 6. Both are increasing, but the ratio maintained is same. It is 1:2, even 3 by 6, 3 1s and 3 2s, even this is also again equal to 1 by 2 or 1:2. So such type of proportion we say it is a direct proportion. X and y are directly proportional to, x is directly proportional to y. Right. So discussing all those, we also started, or we are going to start it now, what is inverse proportion. Just like the reverse of direct proportion. We discussed what is direct, right? X by y ratio should remain constant, but here, if you can carefully observe, the two quantities are in inverse proportion if one quantity increases one should increase and the other quantity decreases. See here, when we have two quantities x by y, in the previous case when we're discussing about direct proportion, I said both of them are increasing. But here, as x increases, y should decrease, or as x decreases, y should increase. Okay, so if one quantity increases when the other quantity decreases in the same proportion, and vice versa, the same proportion. As x increases, y should decrease, or as x decreases, y should increase, and again they should be maintaining their proportion. Okay, I'll give a small example where this inverse proportion can be applied. You can see here, there is a source of light and there is a small puppy coming towards. Let's say the puppy is at this point. Okay, so let's say at this point, from this point, if it sees the light, the brightness will be very less. The brightness will be very less because it is very far away from the light. But as it comes near to the brightness, near to the light, as the distance is decreasing, brightness will increase. Brightness will increase, or I can say in the same way, in the reverse way. Okay, the puppy is moving from this position to this position. As the distance is increasing, the brightness gets reduced. The brightness gets reduced, right? So if one is increasing, the other will be decreasing. If one is decreasing, the other will be increasing. So it follows an inverse proportion. Distance is inversely proportional to brightness, or we can say brightness is inversely proportional to distance. These two are not the same. These two, like distance increasing and brightness increasing, that comes under direct proportion. But here, as one increases, the other one decreases. So such type of thing we say it is inverse proportion. Such type of thing we say as inverse proportion. Okay, so let's try to discuss more about inverse proportion. If y1 and y2 are the values of y, so there is a parameter of the quantity y which is varying. So two different times it has y1 and y2 as the values. If y1 and y2 are the values of y corresponding to the values of x1 and x2 of x. Okay, even x is changing, x1 and x2. In the direct proportion, if you remember, I said x by y ratio should be constant. That means x1 by y1 should be equal to x2 by y2. This is what we get in direct proportion. This is what we get in direct proportion. But in inverse, what's happening? x1 by x2 is equal to, okay, here also tell me what is x1 by x2. If you bring x2 here and y1 here, it is x1 by x2 is equal to y1 by y2. But here, that's not the case. x1 by x2 is equal to y2 by y1. See, the pattern change. 1 by 2 is 2 by 1. And if that ratio is being maintained constant, k, then we can say that they are in inverse proportion. They are in inverse proportion. Okay, so let's move forward. So k is called constant of proportionality. K is called constant of proportionality. If x and y are in inverse proportion, then we say x is in proportional to 1 by y. We read it as x is inversely proportional to 1 by y. X is inversely proportional to 1 by y. Right? So in direct proportion we say x is directly proportional to y. X is directly proportional to y. But here, as we are talking about inverse proportion, we say x is proportional to 1 by y, or we can say x is equal to k by y, where k is called constant of proportionality. Constant of proportionality. Right? So let's move forward. Okay, so we have a question here. We have some applications. Let's try to understand inverse proportion based on these questions, based on these applications. Okay, so what is the question? If 36 workers can build a wall in 12 days, how many days will 16 workers take to build the same wall? 36 workers are taking 12 days. 36 workers are taking 12 days. how many days will 16 workers will take? So definitely you need to understand one thing. As 36 members or workers reduce 16, this 12 days will definitely increase, right? For example, there are 10 members who are working and they're completing in one single day. But in other case, let's say you're the only person who is working on that. So definitely you take 10 days to complete that work. 10 days to complete that work, correct? Okay, so I can say that it is an inverse proportion. And in inverse proportion, just now we discussed x1 by x2 is equal to y2 by y1. Is equal to y2 by y1. Or you can also bring the same relation as cross multiplication x1 y1 is equal to x2 y2. Okay, so we try to use this relation x1 y1. Sorry, it is x1 y1. We try to use x1 y1 is equal to x2 y2. So what we can say here, so this is x1, this is y1, this is x2, this is y2. Okay, x stands for number of workers and y stands for number of days. x1 into y1, 36 into 12 is equal to x2 into y2, so 16 into y2. Okay, so what is y2 equal to? y2 is equal to 36 into 12 by 16. 36 into 12 by 16. So we need to cancel with 3 or 4. So for 3s are 12 and for 4s are 16. Right? So we can cancel with 4 and again we will cancel with 4. 4 1s and 4 9s. 4 1s and 4 9s. So 9 into 3 y2. 9 into 3 is 27 days. So if we have 36 workers, we can complete in 12 days. But we have 16 workers, they take 27 days to complete the same work that has been done here in 12 days. Why? Because the workers are very less. The workers are very less. Even though you have 16 workers, you're taking 27 days. Whereas here, if you're having 36 workers, you can complete that work in 12 days. Right? So let's move forward for the next one. A school wants to spend 6,000 rupees to purchase books. A school wants to spend 6,000 rupees to purchase books. Using this data, fill the following data. Fill the following data. Okay, so see here. Price of each book is given 40, number of books is 150. So you can say 40 into 150, which is equal to 6,000 rupees. Which should be equal to? Which should be equal, I said, inverse proportion x1 y1 is equal to x2 y2. Right? So this should be equal to 50 into some value of y. Okay. So 0 and 0 gets cancelled. 4 into 150 is equal to 5 into y. So 5 1s and 5 3s are 15. So that 0 will be there. So y is equal to 4 into 30, which will give you 120. So we can say that if each book cost 50 rupees, we can purchase 120 books only. The same way, if you're trying to purchase 75 books, then what is the cost of each book? Again, I'm not going to do that now. I'm just giving the same thing. 40 into 150 is equal to x into 75. So from this information, you can try to find what is the value of x. I know 75 into 2 is 150. So 75 ones and 75 twos. So x is equal to 80. Okay. So if each book cost 80 rupees, I can say that we can purchase only 75 books. So in the same pattern, you can do the remaining two. Clear? So let's move forward for the next one. Siri has enough money to buy 5 kg of potatoes at the price of 8 per kg. How much can she buy for the same amount if the price is increased to 10 per kg? Siri has enough money to buy 5 kgs of potato at the price of 5 per kg. So 5 kgs of potato and each costs 8 rupees. For the same amount, now she should purchase few things at rupees 10 per kg. 10 per kg. So can we cancel? Yes. 5 into 8 is 40. Is equal to 10 into x. So 0 and 0 gets cancelled. We can get x is equal to 4. So I can say that if every kg is costing rupees 10, then she can buy only 4 kgs. Then she can buy only 4 kgs of potatoes. Right, so let's move forward. 36 men can do a piece of work in 12 days. In how many days 9 men can do the same work? 36 men can do the work in 12 days. Again, the same type of question which we have discussed earlier. Okay, so 36 men can do a piece in 12 days. In how many days 9 men can do the same work? So from this relation you can try to find that. Right, inverse proportion x1 y1 is equal to x2 y2. Just remember this relation, everything else will be same. Just remember this relation, everything else will be same. Right, so moving forward, if x plus 1 men will do the work in x plus 1 days, find the number of days that x plus 2 men can finish the same work. It's a very beautiful question. Same question that without the values we had, it was given in terms of x. X plus 1 man can do the work in x plus 1 days. Okay, find the number of days that x plus 2 men will take. X plus 2 men to finish the work. Okay, so that will give you x plus 1 into x plus 1 by x plus 2 is equal to, so these are the number of days that they take. Okay, so let's move for the next one. So you can please try to find this one. A car takes 4 hours to reach a destination by traveling at a speed of 60 kilometers per hour. A car takes 4 hours. If it goes at a speed of 60 kilometers per hour, how long it will take if the car travels at the speed of 80 kilometers per hour? And from this information we need to find the value of x. Inverse proportion is very simple. x1 y1 should be equal to x2 y2. If you have the third case, x3 y3. If you have the fourth case, x4 y4, in that way. Okay, so that's all with inverse. A few more questions are there which you can try. 6 pumps are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pumps of the same type are used? 1 hour means 60 minutes. 60 plus 20, you can directly convert to 80 minutes. Instead of hours, if you are confused, convert that into 80 minutes. Okay, so 6 pumps, you can cover that in 80 minutes. Okay, how long it will take if only 5 pumps? So 6 into 80 is equal to 5 into how many minutes? Y minutes. So you can try to bring the relation. Okay, so now let's try to understand what is a compound proportion. We discussed what is direct proportion, what is inverse proportion. Let's try to understand about compound. And when I said direct, okay, as x increases, y should also increases, or as x decreases, y should also decrease. This is about direct proportion. And we also discussed about inverse proportion. In inverse, as x increases, y should decrease, or as x decreases, y should increase, right? So these two are two different proportions. Now in the compound, change in one quantity depends upon the change in 2 or more quantities in some proportion. Here we have only 2 quantities, x and y. Either it is decreasing or increasing based on the value of x. Only one quantity we are comparing. But now change in one quantity depends upon the change in 2 or more quantities. That means now we are having more inputs, x, y, z. Okay, then we equate the ratio of the first quantity to the compound ratio of the other 2 quantities. So what is again this compound ratio? So this one, let's try to understand more about this one. One quantity may be in direct proportion with the other 2 quantities. So let's try to take, there are 3 different quantities in the same case, in the same situation. Okay, so one quantity may be in direct proportion with the other 2, or one quantity may be in inverse proportion with the other 2, or one quantity may be in direct proportion and inverse proportion with the other. There are total 3 quantities. Let's say x, y, z. Maybe all these 3 are in a direct proportion. One quantity is in direct proportion with the other 2, or x is inversely proportional to these 2, or x is proportional to y and inversely proportional to Z. So any such combinations, we say a compound proportion. We say compound proportion. Okay, so let's move forward to learn what is compound proportion. Consider the mess charges for 35 students for 24 days is rupees 6,300. How much will be the mess charges for 25 students for 18 days? Okay, let's try to understand this one. So mess charges for 35 students, and they're eating 24 days a month. The total cost is 6,300. Now, how much will be the mess charge for 25 students for 18 days? See, now what's happening? Are we having only one quantity, or are we having 3-4 quantities? We're having 3 quantities. One, the cost, next students, and the number of days. Everything is being changed. One may be in proportion, in direct proportion or inverse proportion with the other two. That we don't know. Okay, so as we're having 35 students and each student is having 24 days, so per day, okay, so per person, we need to spend 6,300 is the total cost divided by 35 students and 24 days a week, 24 days a month. Okay, the total 6,300 we need to divide among 35 students and 24 days. Now what is given? How much will be the mess charges for 25 students and 18 days? This is per day per student. Per day per student. So the answer is 6,300 by 35 into 24 into number of students. Now it is 25 and the number of days is 18. Number of days is 18. So now we need to cancel these two and we need to find the correct answer. So I'll just tell you small things which we can continue later. 5 5s and 5 7s, and we can cancel with 6 3s and 6 4s, right? We can still cancel 7 63, 7 9s are 63, correct? 7 9, so 900 into 5 into 3 by 4. Okay, so that will give you 6,063 into 100. I'm writing 63 into 100 by 7 into 4 into 5 into 3. 7 1 7 9s, so 9 into 5 into 3 by 4 into 100. So whatever this count is, so that will be your answer. So what's going on in compound ratio? We are not having one quantity, we are having multiple quantities. One may be in direct proportional, one may be in inverse proportion. That we need to understand. See here, as student decreases and the days are also being reduced, so definitely the amount should also be reduced. So that means all the 3 quantities or one quantity is in direct proportion with the other two, right? So whatever the answer you get, so that will be your final answer, right? So this is how you try to relate or you try to find compound proportion, and we have a lot many examples on compound proportion that we are going to discuss in tomorrow's class, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.